Hey everyone, hope everyone's having a good day. Just figured I'd try out this new technology using really an app that's similar to what I would be using in class. That smartboard that I have with the Bluetooth is very similar to this. So I'm going to give it a shot. Haven't used it, so let's see how this works. We're going to go over just a little bit about how to solve these Boyle's Law problems for you in case you're having some difficulty. So the first thing we do is, if you've read through your notes, which I hopefully you have if you are already working on these problems, is that Boyle's law is a relationship between pressure and volume. They're inversely proportional, which means as pressure goes up, volume goes down. And the amount that one goes up is the same as it would go down. For example, if I double the pressure on a volume of gas, then the volume of gas would be cut in half. So the volume of gas would be a lot smaller. It would be half the size. So if think about a balloon, if I take a balloon and I double the pressure on it, the volume is going to be half as much. So that's kind of Boyle's law in a nutshell. The expression that we use helps us to understand what happens if we have starting conditions and then finishing conditions. So we call them initial and final variables. So let's take a look at the formula. It looks like this. We've got P1 times V1, that's our initial pressure, times our initial volume, is equal to P2 times V2. So there's our equation. A form of that is in your reference table, so you don't have to memorize it. We have what's called the combined gas law in there, which will help you to get Boyle's law if you ever need it, which you probably will on our final and whatnot. You'll have to have that formula. But what we do at this point is then we have to make a key. If we're using Boyle's law, we know that we're going to need to have a key, because all of these gas law problems that we're going to learn, Boyle's law, Charles' law, combined gas laws, they can get complicated. So we're going to need to make a key, just like we've done with several other types of problems in the past. So I've got my initial pressure, I've got my initial volume, which is V1, I've got my final pressure, P2, and I've got my final volume, V2. So now I know I got my little key set up. I need to go back into the problem and I need to identify the different quantities that represent these variables. So it says here in the problem that I've got 1 liter of a gas at standard temperature. So there's my starting volume. It's 1 liter. So I'm going to come down here and I'm going to plug that in. 1 liter. There it is. It's at standard temperature. Now, standard temperature is 0 degrees Celsius. It's 0 degrees Celsius. However, whenever we're doing these gas problems, we are not going to be using Celsius. We've got to convert into Kelvin, which you probably read in your notes. And all we do is just add 273 to our temperature in Celsius. So there it is, 273 K. So if it was 0 Kelvin, it would be negative 273 Celsius. If we have the boiling point of water at 100 degrees Celsius, we would add 273 to 100. It would be 373 K. So it's pretty straightforward to do that. And again, that conversion is in your reference table, so you're not going to have to memorize that either. But we have pressure 1 that we're going to have to find. And it says here that it's at standard temperature and standard pressure. So if it's standard pressure, this is also in your reference table, it's 1 atmosphere. Now, atmospheres are easy to use because our standard pressure is 1 atmosphere. I think standard pressure in kilopascals or kPa is like 1017 point something. So it's in your reference table. A lot more complicated calculations. So we're going to use the atmospheres if at all possible. Now it says it's compressed to 473 milliliters. Now I see a problem right away because my initial volume is in liters, my final volume is in milliliters. So I got to convert this. There's a little trick in this problem. So I'm going to put this into milliliters. To do that, I take the King Henry chart and I move the decimal point 3 places to the left, 1, 2, 3, and I get 0.473 liters. Wow. 0.473 liters. So that's my final volume. I never wrote in my starting or my initial pressure, so I'm going to put that in here, 1 atmosphere. And it says what is the new pressure of the gas. So this is the unknown. This is the variable that we're going to solve for right here. So I now have my variables and what the quantities are for each of them. And now I got to plug it into the formula. So the formula says P1V1 equals P2V2. So I'm going to take my 1 atmosphere of pressure and I'm going to multiply it by my initial volume, which is 1 liter. And notice that I'm putting those units in there because we know that it helps us to solve these problems. It'll help us to know if we're solving them correctly if we end up with the proper units at the end. So I have my 1 atmosphere times my 1 liter. I'm going to multiply that by my final pressure, which is the unknown, so I'm going to leave it at P2, times my final volume, which is 0.473 liters. And I just have to now solve this just like I would any simple algebra expression. So if I have an expression in algebra that says 3 times x is equal to 6, I've got to get the x by itself. So I got to divide this side by 3, divide that by 3, and I have x is equal to 2. So that's essentially what I'm going to do with this problem. I'm going to get the P2 by itself. So I've put it over here. Got to get this out of there. Whoops, 473. It's 0.473 liters. Whenever I divide anything by itself, it's 1. So now that cancels out. But I have to do it to this other side. So it's 0.473 liters. And now I have my expression where it's P2 equals, which is what I want to solve for P2. Now my liters will cancel my liters. I'm left with atmospheres, which is what I want for my final pressure. And then I just do the math, and it says that P2 is equal to 1 atmosphere times the 1. I'm just going to leave it at 1 atmosphere, divided by 0.473. And when I do the math, my final pressure comes out to 2.1 atmospheres. And that is my final answer, as they would say on Who Wants to Be a Millionaire. Well, that's how you solve these Boyle's Law problems. If you're having any difficulty, please feel free to email me. The link is on my eBoard site. Most of what we're going to be doing is going to be through Google Classroom, but every day check the assignments on my eBoard site because that's where it's going to be initially posted. So anyway, have a good night, and hopefully you're going to get through some of these. We're going to work on these again tomorrow, and then just like we would do in class, then I will post an answer key. You can check them out and see how you're doing, and we'll move on to the next part of this. Well, have a good night, and thank you very much.